Hey everyone, I'm Jeremy Deshotel. I'm joined here today by my Pomeranian Cash in the back, taking a little nap back there. Um, but yeah, I'm a solutions architect here at Spot. I've been here coming up right on a year now. It's crazy. I got started at the very beginning of the pandemic, and um, it's incredible how much has happened over the last year. But previous to that, I also worked in technical sales for Barracuda Networks and GitLab. Most recently, I was a senior cloud engineer for an online university. I oversaw a migration from a data center into AWS, and then from that lift and shift environment into a greenfield environment where everything was containerized using automated CI/CD pipelines and all of the fun as well as the pain points that come with those things. I'm a lover of all clouds, public, private. I don't know if you can see my image there, but Cumulus, Nimbo Stratus. I like to fly paramotors, which is basically a parachute on my back with a motor and a propeller. And I'm actually from South Louisiana. I'm based out of Salt Lake City, but in Louisiana, we don't have that thing elevation. And so we can't jump off of things, so we need a motor to get us out there. So it's been a crazy couple years getting into the cloud from both a career and hobby standpoint. But yeah, so today we're going to be talking about some of the very issues that Nigel and Kirk were just touching on, which is the infrastructure issues that still currently affect a lot of people today and prevent us from having that seamless experience that we want Ocean to be. And so Spot by NetApp, we're focused on what's called cloud ops, or what we're coining as cloud ops. And it's leveraging those best practices that have over the years kind of been figured out, worked out, gotten all the pain points, the bugs, but also looking at both the DevOps, the underlying infrastructure, the provisioning, the testing, but also the financial side of it as well. So looking at a more of a continuous optimization. And so we've actually tacked on continuous optimization to the CI/CD little figure eight that we're all familiar with. And that's a different perspective. I want you to kind of think of what that would mean. You know, a lot of customers I sit down with today are looking at right sizing. They're looking at, budgets and trying to plan for the next 12 months, the next 36 months. What types of commitments do I need to purchase? Can we right size our applications? Are we using the right types of instances? And so I'd like you to kind of picture, if you will, instead of having to constantly look back and make those types of decisions, what if our applications themselves were able to make those decisions? What if our applications were able to tell us what they need instead of us setting up infrastructure and forcing our applications onto them? And that's exactly what the product portfolio that Spot by NetApp does, is it allows your applications to define and determine that infrastructure and to make sure that infrastructure is always provisioned and ran in the most cost and performance efficient manner. And so just really high level, we're talking about Kubernetes today, but this is our solution portfolio. So Cloud Analyzer is a phenomenal analytics and visibility tool, both at a high level, but even being able to drill down in a very granular manner. And even if you're never a customer of Spot, of NetApp, it's completely free. It's currently only available in AWS with the other cloud providers coming soon as well. It will give you efficiency, cost efficiency optimization scores based on how well you're leveraging the different discount pricing models that the cloud providers offer you, as well as identifying on a workload by workload basis how much more money you could be saving. Elastigroup, think of that as an auto-scaling group or a scale set specifically for running across all pricing levels and provisioning your infrastructure without your input. Eco is our intelligent commitment management system. This is a FinOps team built into a managed service. on a 24 hours a day, 7 days a week basis. It's looking at how much you're spending in pure on-demand compute. Our belief is you should never pay full rack price for compute, and it's intelligently purchasing and selling those commitments, those reservations on your behalf. And then lastly, Ocean, why we're here today is the next level in that vision that Nigel kind of laid out, and that's making the infrastructure layer of Kubernetes as seamless as the underlying plumbing, configuration, security, high availability is today. So Kubernetes and spot instance management. Why spot instances? Well, spot instances are almost ephemeral in nature, as containers are. And so if your applications can be spun up and torn down on a moment's notice, we don't necessarily need to pay for these long running instances. And so let's just kind of take a step back and let's level set on Kubernetes for anyone who's not very familiar. But let's just look at the anatomy of Kubernetes. So we have our control plane, which is where a lot of that underlying plumbing lies. That's where the data store is. That's our API server. That's the scheduler that schedules your applications onto the different nodes. And so that is not something that we touch. Okay, that's where a lot of the configuration is, but 80 to 90% of your costs lie in the data plane. This is where your worker nodes are. This is where your applications live. And this is what we intelligently provision and optimize on your behalf. So there's really two layers of scaling that we kind of need to think about when it comes to Kubernetes. And so the first one, infrastructure as a service, right? That's our instances, our virtual machines. And so there's a lot of today, deciding what instance type, what instance size, do we need an SSD or not? Can we get away with a magnetic disk? How much throughput do we need? All of these decisions that are kind of mapped out today, and like Nigel said, we're not every team has tons of infrastructure engineers that can sit and map all of this stuff out. When they should be innovating, they should be working on new applications. They should be focusing on what differentiates their company from their competition. And so we want to be able to focus strictly on the application layer. And so that's what Ocean's going to do for you. So if we look at the application layer, let's look at what solutions are out there today. So we have our horizontal pod auto scaling, and that works very similar to horizontal scaling just with virtual machines, like an auto scaling group or a scale set. So there's a metric, maybe CPU utilization or memory utilization that we're watching for. And whenever it crosses a threshold, we will either tear down pods or instances, or we will add pods or instances. We also have the vertical pod auto scaling today, and that works almost as a form of right sizing. If we're requesting a certain amount of resources, but our application actually needs much more, a vertical pod autoscaler can go ahead and increase those resource requests. And then on the flip side, what usually happens is the developer won't provision exactly what they need. They'll typically provision 1.5, 2, 3, 4 times as much just to make sure that everything works. And so that leaves a lot of room for waste. Vertical pod auto scaling can help with that.
Hey, Jeremy.
Yes, sir.
Before we get too much further, I want to ask, because I think you lost me here. I just want to make sure that I'm clear in what I heard. Did you say, obviously, you're focusing on the application and the pods, so the control plane, are you guys managing the control plane, or is that something I have to have in place and then you come in with this and manage the pod orchestration and things like that?
That's a great question, Larry. So we do not control your control plane. We do not manage the control plane. We sit as a single pod in your control plane, but we handle the provisioning and scaling and scheduling in purely the data plane. Okay. A great benefit there, means that it doesn't matter if you're rolling your own using COPS yourself to manage your clusters. If you're using one of the managed providers, our most popular use case is probably EKS with Amazon, GKE with GCP or Azure AKS, or even if you're using Docker Swarm, if you're not using Kubernetes, if you're using Docker Swarm, if you're using Amazon ECS, we integrate with all of those the same.
Okay. So I did hear, or I did not hear. Anyway, I was correct in what I thought I heard or didn't hear. So that's good. So you guys you just install as a pod within the control plane, and then you correlate and work with the existing scheduler, and then you manage all the infrastructure or the pod deployments and things like that.
Correct.
Okay.
The way we do that is by, as we kind of painted that picture, making your application, right? Making your pods first-class citizens, listening to them. And so what that controller does is it sits on that master node. It's listening to the metric server, and it's also getting any pending pods. And so the second it gets a pod that needs to be scheduled and there's not enough infrastructure there, then based on the resource request of the pods, it will determine the appropriate instance lifecycle, the appropriate instance size, the appropriate instance type, and it will provision that.
Awesome. Thank you.
Absolutely. So the problem we still have with most of the solutions that are out here today, or the way most people are running Kubernetes, is that, again, first priority is making sure we're meeting the application demands. And we don't have to worry about scaling if we just say something like, yeah, let's just run 20,000 instances, but obviously we would probably go bankrupt tomorrow if that were the case. And so the issue is we want to make sure we're meeting our demands, yet still doing so in an efficient manner, minimizing, those idle resources. And so there's 3 layers of optimization that takes place in an automated fashion with Ocean. And so the first one is the life cycle. Ocean can manage your worker nodes, your data plane across all 3 pricing models today. So we can primarily run on spot instances or preemptible VMs if you're in GCP, where you get the overall greatest cost savings possible, 70, 80, sometimes even 90%. We can run on reserved capacity. And what's great about Ocean is it can see all of your commitments in your account. It can make sure that you're at 100% utilization, because if you're not at 100% utilization with your reserved instances, you're leaving money on the table. These are instances you're paying for, but you're not running them. And so before we ever run a spot instance, we'll actually launch an on-demand to fulfill that commitment because you're already paying for it. And then if we need to, fall back to on-demand to ensure capacity. This allows us to offer the same enterprise 4.9 SLA on workloads that run on spot instances that AWS will offer you for on-demand instances. And so no other cloud provider offers an SLA on spot, but the workloads ran and orchestrated on spot using Spot by NetApp, we give you a 4.9 SLA there.
Yeah, I have a question regarding how you're packing the pods onto the various worker nodes, because you mentioned the different scaling, and it sounds like you're kind of doing like bin packing. You're like, how do I maximize the number of pods per instance so there's no waste? So are you using some sort of algorithm to figure that out, or is some other technology that scales and decides which pods get scheduled where? Are you sort of overriding Kubernetes orchestration in that regard?
Great question. So we're not overriding. We're taking into consideration all labels, taints, affinities, tolerations. We're taking all of that into consideration when we're making those scheduling, decisions. What we are taking away or abstracting away is the management of many different auto scaling groups for every particular instance size, every particular instance type, and we're just scheduling the pods onto the worker nodes the same way Kubernetes does. We're just replacing any cluster autoscaler and scheduler that you might already have in place.
Okay, so if you see that there's an opportunity to better schedule the pods in a way that'll get you at that 100% utilization, are you going to kill pods and respawn them to kind of juggle things around?
Uh, Yes. So I'll answer that question a little bit more in depth and show you how that actually works. But yes, every 10 seconds, Ocean looks at the makeup of the cluster, all of the pods running on all of the different nodes, or all of the tasks running on all of the container instances if you're using ECS. And then it says, is this the most efficient way that this cluster can run? If the answer is no, we're looking for underutilized nodes, the pods on those nodes, if we can reschedule them onto other existing nodes, and then thereby terminating that node, reducing the overall footprint of your cluster. That process happens again every 10 seconds in a completely automated fashion. We run scenarios on what would be the most efficient way to reschedule each pod, respecting any pod disruption budgets, anything like that. And that usually frees up anywhere from 15 to 30% of your cluster.
Wow, that's pretty cool. Thank you.
Absolutely. And then the last layer of optimization is going to be the pod right sizing. And so that is the application layer. We can optimize your infrastructure all day long, but if you're requesting 5 times the resources you need, it doesn't matter. You're still leaving a lot of money on the table.
So I have a question about the pod right sizing. Is that going to help developers or collect metrics to help determine the resource requirements for your app in the pod? Because, that's something that's often overlooked is people just deploy pods and don't set CPU limits or minimums. So is there something in Ocean that helps with that?
Yes, absolutely. So that's going to be our right sizing. So that's where the pod right sizing comes into play. After running for 1 week, taking into consideration nights, weekends, things like that, we start giving you right sizing recommendations. Now, we're very conservative with those. So what we do is we look at the resource requests that your developers are making, and then we make a recommendation based on the absolute maximum amount of resources that pod has ever consumed. Today, it's at the deployment level. Very soon, it will be at the individual container level, but it's currently at the deployment level. And so, yes, that will help. Now, it's only a recommendation. We recommend, engineers talk to the developers, make sure there wouldn't be any issues if you go ahead and, cut the resource requests. But once you're comfortable with that, we actually have an open source mutator working very similar to a vertical, pod autoscaler that will do that on your behalf for you.
I have a quick question as a follow-up to that. So I hear what you're saying about how it's measuring the resources at the pod layer. Is there any one of the things that I've run into when talking about right sizing initiatives is that conversation with the developer and trying to get that next layer of like application performance as the nail in the coffin to get a good right size recommendation. Is there anything that you're going to talk about, or is there any future consideration for like tying it into like AppD responses or something like that to like close the loop on a good right size?
Could you elaborate a little more on the close the loop on a right size?
So your right size recommendations, I'm assuming, are on the 4 food groups: networking, CPU, IO throughput, and things like that. Is that accurate?
So it's currently just CPU memory,
Okay.
but yes.
Sure. The next layer. So when you're getting into that right size conversation with the developer, they're like, yeah, but how does that impact my performance? The old talk about like, JVM machines, I need that 8 gigs of RAM because the JVM machine needs it, but it doesn't look like it in the results of the right size. So that was always the battle for doing a good right size. Mm-hmm. is getting that piece. So if there's a mechanism to do that, then that would be like the magic sauce.
Right. And so unfortunately, I mean that differs from application to application. You know,
Exactly.
that's such a unique and custom, issue that's very hard to address, and we don't address that. Um, what we do take off the plate in terms of, communication between infrastructure and development is having to pre-provision auto-scaling groups and launch configurations and all of those different things. The developer can specify what they need in, in their pod spec, and Ocean will take that and make those infrastructure decisions on the fly, without all of that needing to be configured, set up, tested, before the developer is ever able to deploy. So one of our customers, been a customer for a long time, Ticketmaster, for instance, they now, because of this solution, have only 3 engineers managing their entire Kubernetes infrastructure for over 1,400 devs, just by taking all of that pre-configuration out. Now, in terms of right sizing, again, we don't have that in place today, but that's definitely the next step.
Okay,
So
cool. Thank you.
let's talk about what that concept looks like. That nodeless, that serverless containers experience. What does that mean? So we don't need to, not only do we not need to manage the underlying infrastructure, we don't need to have any knowledge of it whatsoever. We want to deploy our applications and have Kubernetes figure it out. We don't want to scale with metrics and cooldowns and time periods. We want to scale in real time. What that means is if we have a pod that needs to be scheduled and we don't have the infrastructure for it, we need to create that infrastructure, not wait for a 5-minute period or a certain threshold to be hit. Utility billing. We only want to pay for what we use. We don't want to pay for something we're not getting. We want to be able to scale all the way down to 0. If we're not running any applications or workloads, why would we continue to run instances? And we want to be able to scale fast. We want to be able to handle bursty workloads, again, not waiting for thresholds, and we want to satisfy the needs of our applications immediately. So if we were able to solve all of these issues, that would be a pretty great next step of that vision that Nigel was painting in the beginning. So how does that look? So your pods, your containers, that spec, right? That's where you can define exactly what your application needs. And understanding that Kubernetes speak, the Ocean controller is able to then provision the right infrastructure, taking into consideration and respecting everything that you currently have in place. This again is a good little diagram of where Ocean sits and what it does. So regardless of your control plane, we don't manage your control plane, we sit on it. But regardless of what control plane you're using, we will handle that data plane management for you. So here's an example of the bin packing and intelligence that goes into Ocean. So let's say we have a pod that requests 6.5 cores and 8 gigs of memory. So we've chosen, we've looked at the numbers, we've looked at the instance types, we've chosen an M5 large. The M5 large has a little bit more than that. We're running about 81% memory utilization, 75% CPU. Most people would say that's pretty good. Workload spins up a little more. Now we need a couple more pods. So we spin up an XL, which has exactly twice the memory, twice the cores, and we can fit an extra pod on there. So we're at the same exact utilization percentages, and we're spending the same amount per pod. But if we look at the 2XL, because of that 81% and that 75%, there's a little bit of waste there. If we look at a 2XL, we can actually not have 4 pods, but we can fit a 5th pod on there. So if we get to the point to where we have 4 or 5 pods, Ocean's intelligent enough to run these scenarios, again, every 10 seconds and say, hey, we can significantly reduce our per pod cost by moving 5 of these into a 2XL. And so this is the type of intelligence and optimization that is happening on a continuous basis for all of your workloads running on Ocean.
Hey, Jeremy.
Yes, sir.
And I assume you're going to get to this probably when you do a demo or something, but I just want to ask in case we don't. From the perspective of defining my deployment manifest and all that, my spec, do I need to define in the manifest to use Spot? Or do I not have to care? Because I mean, obviously, you know where I'm going with this. So.
Right. Yeah, so that's a great question. So I'll show you exactly how we do it in a minute with the COPS cluster. So it really depends. In a COPS cluster, I can put a couple different labels on my instance groups, run a COPS update, and that's it. Obviously, I have to have a Spot account for it to be deployed into, but that's it. For EKS, we can create a brand new cluster attached to an existing one. We can do it in the UI. We can do it via our CLI tool. We can do it with direct API calls. We can do it with Terraform, CloudFormation. We integrate natively with however you're currently deploying your infrastructure.
So what I wonder is, on paper, this looks great because it optimizes my cost, but does this also factor in the performance of the pods after changes? So for instance, it moves to an M5X large. Does it factor in the performance loss or gains? Does it actually monitor that to see if the application is still performing?
So it would really come down to how you define that performance. Your generic CloudWatch metrics are going to be captured, any custom metrics you want to capture as well. So a lot of times what we're seeing, and we see it here with the C5 and the M5, where we actually can, CPU is much more expensive than RAM. And so a lot of times we can actually use a higher memory instance, waste that extra memory, but be optimized on the CPU side and still save money. To answer your question specifically, we're not benchmarking individual instance types. We're scaling based on the resource needs of the application and anything that's applicable to that application, but we're not benchmarking millisecond latency and overall throughput on those types of things.
So not to take up too much more time here, but just a follow-up question to what you was getting at. When do you make decisions about when to scale to avoid contention? We're going to run these hosts really hot, 90% CPU, 80+% RAM. At what point do we decide, that could be an issue. We want this to be invisible to developers and not introduce any kind of performance issues due to contention. And now it's time to scale.
Yeah, that's a great question. So if we're running at, for example, 95% utilization and we have a bursty workload, is that an issue? Is what I'm okay. Yeah, great question. And it can be, but Ocean has a solution for that as well. And that's our automated Headroom. And so by default, and it's completely configurable, but by default, it takes the most common pod resource requests, and it automatically creates a buffer across your cluster for about 5% of that. Now that can be configured all the way up to actually 200%, but you can have that buffer and you can do that on a per node group level. You don't have to manage node groups with Ocean, but you can do it on a per node group or per workload basis and have that buffer. And the way it works is that exists for instant schedulability. And then the moment that threshold of 5%, 10%, whatever you configure is crossed, well, then as those pods are being scheduled, we're spinning up additional infrastructure in the background. So we always stay a little bit ahead. And so for any bursty workloads, that's how we handle that.
I was just wondering that, could it be a runaway process? So if the infrastructure keeps growing like that, is there any check on that? Because it could be a rogue process eating up all the different resources. Are there any controls over that? Is there a limit to that growth?
To the Headroom?
Yeah, to the Headroom, because like you were saying that it starts catering for the next level of Headroom. once
Right.
you start getting into that. So where does it stop?
So, it stops whenever that buffer is, arrives. So if you have 20, if your most common pod, if your biggest deployment has 20 pods running, it will, and you have it set to 5%, it will have enough resources for one pod. And so the minute that's scheduled, another node gets spun up. Well, if you can have more than one pod on a node, it's not going to spin up another, instance until that's consumed as well. And so it's not necessarily a runaway process unless you were spinning up extremely small instances and then you had daemon sets that would be scheduled on them and then take up the room. And so you'd have to spin up another, unless you did something like that, it wouldn't be a runaway process. It's always just keeping a percentage of what's actually running on the cluster now as available, space.
Right. I mean, my point was that, it could be a mistake. It could be a runaway process. It could be anything. So if there is a control where it says, okay, fair enough, you've done it 3 times already, don't do any more than that. Is there?
Yeah, you can set hard limits. Again, it's completely configurable by you, and you can set it to be percentage based, but you can also set it to be based on exact amounts of, I want, 8 cores available and 12 gigs of RAM across my cluster at all times. So you can set hard limits, you can set it percentage based, completely configurable by you.
All right, thank you.
So we're talking about the scaling, and you're talking about changing the instance size. And I know with that comes the amount of NICs and IP addresses you can have assigned, especially in EKS if you're using their CNI for the AWS networking. Does Ocean account for that differences? So say you scale down, but now you can only have 1 NIC card, or you can only have 10 VIPs, right? And then now you can't deploy as many nodes to that instance. Like how's that addressed?
Okay, you're saying the CIDR, the way you have your CIDR configured.
Well,
to
no.
where...
So the CNI, well, unless they've changed it, it's been about 1.5 years since I've tinkered with it. But before, if you're using the AWS CNI, right, then you only can assign the number of IPs per pod based on how many IPs can be on that NIC, right, and how many NICs can be on that box. So depending on how your scaling is going to work, you might end up in a situation where you don't have enough IPs to deploy as many pods to that node as you want to.
Right. So I've ran into that once or twice for very specific workloads. And in that case, what we've done is we've either just eliminated, you can create either a whitelist or a blacklist of instance types. And so we've either just blacklisted very small or very large nodes, the very large ones obviously being able to hold more pods and therefore more IPs than you're able to assign. And that's been able to take care of that. I'm going to just jump straight into the demo. So I have these 3 deployments. They're all spun down right now. We just have one node. It's a T3 large. And so if I go ahead and, let's scale these up and see what happens. And so I have a couple auto scaling groups in AWS. And so if I want to scale this, what we're going to see is that it's going to schedule that pod, no problem. So those 3 pods. Now let's do the same thing again, but let's do it with, and actually let's look at what these deployments are. And so it's just a Nginx container. We're requesting on the medium size one, 0.8 cores and 2 gigs of memory. So if I scale that one up as well, what we're going to see is those are going to stay in a pending state. Now, most people would say, "Oh, well, that's not an issue. That's a perfect solution for, or a perfect problem for the cluster autoscaler." And you would be right, but that's where the problem lies, is we have to manually set up autoscaling groups. We have to know the resource request ahead of time of the application that's going to be deployed into that instance group. And we have to make sure that our configuration of our infrastructure is going to support that. So with Ocean, we can abstract all of that away. So in this case, let's go ahead and let's import this cluster into Ocean. So this is for COPS. If we look at the COPS documentation, all we have to do in addition to creating a bearer token is add a couple feature flags. And so SpotInst hybrid, what this allows us to do, we put this label on our instance group, and then we can actually both manage the infrastructure using autoscaling groups and Ocean. And so your cluster autoscaler or your autoscaling groups can almost act as a fallback mechanism, but we can actually have Ocean handle all of that. So all we have to do is add a couple labels. And then the only other thing we have to do is we have to have a default instance group. So I actually created one called default. It's got a minimum maximum size of 0, but I'm just going to add that same label here for hybrid mode. So that way it can be managed by both AWS as well as Ocean. And then I just need to add this label right here, default launch spec. So that's it. I run a COPS update cluster. And then I can do a rolling update. And I actually have a script. And then if we go over to the Ocean console, we can see that it actually created a cluster. We can see it's updating my group. It's spinning up new instances. And let's see. Now let's do this. While this is happening, let's go ahead and do the exact same thing. Let's scale up this workload again. And let's scale it to 30 replicas. Now, if I go into Ocean and I watch the logs, what we should see let's see if the pods are pending yet. It might still be doing the cluster roll. Yep. Okay, so the cluster roll is still going on. What I want to do is show you in an already running cluster what that looks like. So if we go back to those 3 optimization layers that we were talking about, showing you a production cluster, this is what we're going to see. So the first thing we're going to see is the lifecycle provisioning. We're going to, assuming you don't have a bunch of reserved instances that you're paying for and not using, we're going to orchestrate your workload pretty much predominantly on Spot instances. And let's go ahead and pick a cluster. And so as you can see up here, this is an EKS cluster. We're running about 300 nodes here. It would cost, if this was running on demand, almost $120,000 so far this month, and it's actually cost only 43. So roughly a 63% savings. But that savings rate's misleading because we'll save you 30 or 40% before we ever orchestrate on Spot instances. The way we do that, again, first, the bin packing algorithm. So if we click on nodes and look at the nodes running in this cluster, but what you're going to see is these almost unbelievable utilization rates. And the ones you see above 100%, that's just where the requests were way more than the application actually needed, or they were right sized after the fact. It's not actually using more resources that are there. But you'll see these percentages that are almost 100%. And if you see the light blue and the light green, I believe it was, I don't know if it was Ned or who was asking me about basically that buffer, right? If we're running at 95%. So this light blue and light green you see is actually that buffer on these existing nodes. But again, every 10 seconds, Ocean is looking for these nodes that might be a little underutilized. And if we look at the logs and we find one of these times where we scaled down an instance, you can actually look at the pod rescheduling simulations that happen. And so it's running these simulations on each node, seeing if we respect pod disruption budgets, labels, taints, annotations, can we reduce the footprint of this cluster? And then it's making those decisions. The right sizing, we had talked about this. So if I pull a cluster that's not currently updating, we'll see what that looks like. And this is just a demo cluster, so these numbers are going to be very small, but you'll get an idea. And so after 7 days, you start getting these. And so the delta here, like this was early on when the cluster was running, the delta is your waste. This is how many resources you're saying you need versus how much the workloads are actually consuming. And so again, this is on a deployment basis now, but that will very soon be on an individual pod basis. And then lastly, cost analysis. So if you are using, regardless of if you're using multi-tenant clusters today, this is going to be very beneficial for you. But if you're at a company that's currently using multi-tenant clusters or you're considering it, this is going to make your life much easier. And so what this is our cost analysis strictly for Ocean. We can filter and group by namespaces and labels. We can add filters and condition sets, and then we can drill down. What many customers do is they'll assign each team their own namespace. We can look down to the dollar and cent cost on both compute and storage for every single deployment, the percentage of that namespace, and then that namespace's percentage of the overall cluster. We can export this on a regular basis, Excel spreadsheet, CSV. We can basically connect our SSO, create an audit account for, FinOps team, or basically support your cost showback needs in any way, shape, or form. And then lastly, the pricing model. This is a negative cost product. We're a success-based company, which means we don't make we don't make a dime until we've put $1 back in your pocket. So the way that we charge is purely based on the money that we save you. And then at the end of the month, based on the amount we've saved you on compute, you just kick back a small percentage of that to us. So this is not something that costs budget. It's something that frees up budget for your other needs.